Welcome. In this lecture, I am going to solve NEET 2026 questions in physical chemistry under the topic of some basic concepts in chemistry. Okay, let's see the questions. The first question is the numbers 17.0145 and 21.0235 were rounded to three figures. After the decimal points, the resulting number would be. Here they given four figures after the decimal point. We need to convert into three decimal figures after the decimal points. There is a certain rules. Okay, we have two set of rules. If the last digit is 5, this rule is used. If the last digit is not 5, this rule can be used. In this case, the last digit is 5. We take the second rule to solve this question. If the preceding digit is even, what is mean by preceding digit? Preceding digit is a digit before the last digit. In first case, the 4 is the preceding digit. In second case, the 3 is a preceding digit. The preceding digit is even, it is unchanged, which means leave it as such. If the preceding digit is odd, the preceding digit is increased by 1. This is a rule. Then how to solve it? It is so simple. 17.0145. The preceding digit is even, so leave it as it 17.014. This is the answer. In another case, 21.0235. The preceding digit is odd, so increase the preceding digit by the unit 1, 0 to 4. These two are answers. If the last digit is not 5, then these two rules can be used. If the last digit is less than 5, retain the preceding digit as it is. If the last digit is greater than 5, increase the preceding digit by 1. This is the two rules for scientific rounding of decimal figures, decimal numbers, etc. This is the second question. The amount of carbon dioxide evolved upon complete combustion of 116 gram of N-butane. Combustion reaction is a reaction in which carbon dioxide is emitted. N-butane is nothing but it contains 4 carbon atoms: carbon 1, carbon 2, carbon 3, carbon 4. Here CH3, CH2, CH2, CH3. That is 4 carbon, 10 hydrogen. React with the oxygen. Combustion means in presence of oxygen, it gives carbon dioxide plus water. There is 4 carbon, so 4 carbon dioxide. There is 10 hydrogen, 5 H2O. Here 5 oxygen, here 8 oxygen. 5 plus 8 is 13. So 13 O2, which means 26 oxygen. So 13 by 2. It gives 13 oxygen. 1 mole of N-butane react with the oxygen to give 4 mole of carbon dioxide. 1 mole, which means how many grams? C4. There is 4 carbon atoms, so carbon mass is 12. 12 into 4 plus 1 into 10, which is equal to 58 grams. For carbon dioxide, 12 plus oxygen is 16. There is 2 oxygen, 16 into 2 is 32. Plus 32, it will give 44. 1 mole equal to 58 gram of N-butane gives 4 moles of 44 gram of carbon dioxide, because it is a 4. So it is here, it is a 4. They are asking 116 gram. Then how to solve this? This is so simple. Okay, for 1 gram of butane, 1 gram of butane gives 4 into 44 gram divided by 58. Okay. The final answer would be for 116 gram, multiply 116 in both sides. 116 gram of N-butane gives 4 into 44 divided by 58 into 116. This much carbon dioxide is emitted in grams because they given in grams. So the carbon dioxide amount is also in, which means should be in grams. If we solve, we get the answer like 352 grams. This is so simple. Just find for 1 gram of N-butane gives how many grams of carbon dioxide. Then multiplied by 116 gram, it will give the 116 gram of N-butane gives how many carbon dioxide in grams. The number of hydrogen atom present in 5.4 gram of urea. What is urea? Urea is nothing but it is a NH2 C double bond to NH2. There is 4 hydrogen. The number of hydrogen atoms present in 5.4 gram of urea in simple urea, which means 1 mole of urea. Okay, 1 mole of urea contains 4 hydrogen atom. Okay, only 1 mole of urea contains 4 hydrogen atom. Okay, they are asking 5.4 gram of urea. We need to convert mole into gram. This is our first aim. Okay. How to convert gram into mole? Okay, mole is nothing but weight divided by molecular weight in simple manner. Okay. Weight is given 5.4. Molecular weight is 60. How it is 60? For nitrogen it is 14. Carbon is 12. Oxygen is 16. Hydrogen is 1. Just add everything, you will get 60. Okay. The number of moles is 0.09. Okay. In 5.4 gram of urea, there is 0.09 mole of urea. Separately, 0.09 mole of nitrogen is there, 0.09 mole of carbon is there, 0.09 mole of oxygen is there, then 0.09 gram of hydrogen is 9 mole of hydrogen is there. Okay. Then what is a formula or else what is a method to find the number of hydrogen present in a particular amount of one chemical substance? There is a small formula. It is from basic fundamentals. Okay, it is not a big thing. Okay, kindly note the number of molecules and the number of atoms difference. The number of molecules, which is equal to moles multiplied by Avogadro's number, just like number of atoms, which is equal to moles into Avogadro's number also multiplied by atom per molecule. This is a rule to find number of moles in a particular amount of a chemical substance, not in a mole. If it is in a mole, we can say simply there is a no problem, but they have given in grams. Okay, to find number of moles in a particular gram of a chemical substance, this is a formula. We need to find number of moles and multiply it by Avogadro number. Okay. But they are asking number of atoms. Okay, moles is nothing but 0.09 is moles, we already found. Then atoms per molecule, there is a 4 hydrogen atom in urea, structure of urea, there is 4 multiplied by Avogadro number 6.023 10 to the power 23 plus 23 it will give the answer 2.168 10 to the power 23. This much of hydrogen present in 5.4 gram of urea. This is a number of hydrogen atom in a urea. If it is in a gram, if it is in a mole, it is so simple, but they have given in gram to confuse us. Okay, there is only two formula. This is so simple one. Then this is a final question. This is so simple. This question is very simplest question. It is just a mental ability, not a chemistry. Okay, just to look on the basis. When 1 decimeter cube of carbon dioxide, 1 decimeter cube, it is nothing but 1 liter. Okay, 1 liter of carbon dioxide when passed over a hot coke. Coke is nothing but just a carbon. The volume of gaseous mixture after complete reaction at STP becomes 1.4 decimeter cube, 1.4 liter. The composition of gaseous mixture at STP. They are asking the composition. Composition means there is a two different gases or else more than one gases. Composition is always talks about more than one. If it is only one, there is a no word composition. Okay. When carbon dioxide passed over the hot coke is nothing but carbon, it will give carbon monoxide. So one carbon dioxide create two carbon monoxide. Okay, just like 1 decimeter cube of carbon dioxide passed over coke. There is no word how many coke is there. Okay, they won't mention anything. They didn't mention anything. We don't worry about that. Okay, it's just a coke. It will give 2 decimeter cube of carbon monoxide. Okay, but they give you 1.4. 1.4. This is not a case. This is a case. Then how to find? Simply thinking 0.4 gram of, 0.4 decimeter cube of carbon dioxide react to give 0.8 decimeter cube of carbon monoxide. This is acceptable because it is doubled. When 1 decimeter cube of carbon dioxide react with coke to give 2 decimeter cube of carbon monoxide, just like 0.4 decimeter cube of carbon dioxide react with coke to give 0.8 decimeter cube of carbon monoxide. This is acceptable. Okay. I am going to solve from this basis. Okay. This is so simple. 1 decimeter cube, I will take 1 as a 0.6 plus 0.4. This is 1. 0.6 plus 0.4. In 0. Which means in 1 decimeter cube of carbon dioxide, only 0.4 decimeter cube of carbon dioxide react with the coke to give 0.8 decimeter cube of carbon monoxide. Okay, the rest of this remains unchanged. Okay, if we add 0.6 plus 0.8, 1.4 is the answer. Okay, the solution is in 1 decimeter cube of carbon dioxide, only 0.4 decimeter cube of carbon dioxide react with the coke to give 0.8 decimeter cube of carbon monoxide. Then the total volume will be 1.4 decimeter cube because 0.8 plus 0.6 plus it will give 1.4 decimeter cube. Okay. Then the volume of the gaseous mixture. The gaseous mixture is nothing but carbon monoxide and carbon dioxide. In that gaseous mixture, 0.6 decimeter cube of carbon dioxide and 0.8 decimeter cube of carbon monoxide is there. This is a simple solution. There is no need of any mathematical calculation. It is all about our mental ability. This is clean and clear. Okay. 1 decimeter cube, we need to separate one as a 0.6 and a 0.4. This is a solution. Okay.